Hey guys, welcome to today's session. Today we are diving into something powerful, fundamental, and absolutely essential in the world of data science and machine learning, which is linear regression. Okay, just think of it as a magical formula that helps us predict the future. Okay, whether it's forecasting sales or estimating house prices or even predicting the success of your next big idea. Okay, linear regression, the foundation of it all. Okay, so by the end of this session, what you are going to learn, you will be understanding what linear regression really is. Okay, and break down the slope and intercept like a pro and build a simple linear regression model from scratch using Python. Using Python, the I'll be using a scikit-learn package. Okay, and stats models also will be using it. Okay, and then interpret the results in a way even a non-data folks can also understand. Non-data science guys can also understand. Okay, so buckle up, and if you feel sleepy, grab your coffee and let's get started on this awesome journey into the world of linear regression, guys. Okay, what is linear regression? It is a supervised machine learning algorithm. We already discussed, right? So it is used for predicting the continuous numerical outcome value. And also, the reason why we are using linear regression is one of the key reasons, to establish the relationship between independent dependent variable. To establish the relationship between independent dependent variable, and also it helps us to understand, right? So the relationship, yeah, between the variables, and then future important analysis. Importantly, right? The future importance, you can do it. Okay, what do you mean by future importance analysis? You can find out which features are helping you much in terms of predicting your target outcome variable. Okay, that is what this one says, the feature important analysis. Okay, we can use scar plot, using which also you can find out which features are really helpful, right? What relationship exists between the input features and the output feature. We discussed about all the jargons in the past session, right? Okay. So what are the types of linear regression? One is simple linear regression and multiple linear regression. What is simple linear regression? In the case of simple linear regression, we'll be having only one independent variable or the only one input feature. Okay. But output feature should be there. Only one output feature, only one input feature. When it comes to multiple linear regression, here also same. The output feature is only one. The dependent variable is only one, but the independent variables are more than one. That is what your multiple linear regression. If you have more than one feature, in your model, that is called your multiple linear regression. One second. So here, okay, this is the equation for the simple linear regression. Okay, beta naught. What is beta naught? Beta naught, since I was not able to put the beta naught notation, this is what your beta naught and this is what your beta 1. Okay, beta 1 x1. But school time, you must have studied y equal to mx plus c. Okay, the c is the constant, which is intercept, and m is your slope, and x is your independent variable or the input feature. Okay, that is the linear regression equation, right? Linear algebraic equation. Okay, the same thing here. Instead of the c, I'm using beta naught, and for m, I'm using beta 1 and x1 plus e is an error. Okay, this is what is simple linear regression equation. Okay, what is this? Okay, one second. Now, okay. Before we understand what exactly beta naught and beta 1, right? What is intercept and what is slope? Okay, let us do a simple math. With that, you should be able to understand how the model predicts. For example, you wanted to predict the housing price. You want to predict the housing price. Okay. In that case, what you do is you take historical data and then you train your model. One second. You take your, train your model, train your machine learning model, train your ML, machine learning model with historical data, which contains both input feature and the target output. Okay. Train your ML model with historical data which contains input feature and target output feature. Okay. That's fine. So this is my ML model, right? This is linear regression model. Linear regression model. You take this data, and then you train your model with the historical data. Once you train your model, right, you apply the model on the new data. For example, you train this linear regression model with the housing price data set. Okay, housing price data set, the historical housing price data set you took, and then you trained your model. This historical housing price data set contains both the input feature and the target output feature. Okay, you train this model. Now, the model learn the pattern from this historical data, housing price data. And then once the model learns the pattern, your model is linear regression model is prediction ready. And with this linear regression model, if I ask you any questions, right? For example, if I give you 100 new houses, the size, the input features, 100 new houses, input features, you need to use your linear regression model, and then you need to tell, hey, for these 100 houses with the given input features, these are the predicted housing price, because your model already got trained by the historical. But if you have to tell the 100 houses estimated or predicted the housing price, it will take more time, right? You need to check, okay, this one is from this location, this is the age of the house. So what are the input features here? We already discussed. For example, size of the house, and then the age of the house, and then the area. Area is nothing but the location, right? And then nowadays the parking lot also, right? How many number of parking lots? Parking lots. Okay, parking lots. Okay, size of the house, age of the house, area of the house, and then number of rooms. Number of rooms also matters. Number of rooms. Okay, so these are the key features. These are the input features. If I give 100 houses, with these features related data, and if you show it to your model, you show your model to say, hey, for house one, this is the price, and for house two, this is the price. Okay, it has to predict the housing price for the 100 houses by given this set of input features. But here I did not give the housing price. Why? Because in my historical data, I already given all the features. Along with that, I mentioned about the housing price also. Okay, the housing price is a target output feature. These are the input feature. So give both input and output to your model. The input is set of features, these features, and output is housing price also. You trained your model. For the houses with this size and with this age and in this area and with this number of parking lot, this is the housing price. You just gave the question and answer to the model. Model learned the pattern. Okay, that is the beauty of any machine learning algorithms. Okay, it learns the pattern automatically. And then if you show 100 or 1,000 houses, the set of these features related data to your model, it automatically predicts, all those houses, estimated or predicted housing price in a matter of seconds. Okay. So that is what machine learning model, we already learned about this. Right. So in this case, what I'm going to do is to make this very simple, let's say Y is your housing price. This Y is your housing price, and beta naught plus beta 1 x1, and let's forget about the error. Okay, so is equivalent to what is x1? X1 is your size of the house. Okay, let's say that's 1,000 square feet. This is what your x, okay, or x1 or x. Okay, and this is your intercept, this is your slope. Okay, you don't have to worry about computing the intercept and slope manually. I will tell you what is the formula for this one little later. Let's go by the statistical software. For example, if you fit a model, you train, what happens is the Python or any statistical software, it automatically estimate the value for the intercept and slope. You don't have to compute the values for this. For example, here the beta naught is, let's 1, 3, 2, 5, and beta 1 is something like let's say it gives only 2, okay, something like that. 2 into, this is your slope, and this is your x1. X1 is your square feet, and the beta naught is already calculated by your model 1325. So 1325 plus 2 into 1000, 2000, and you need to add these two things, 3325. If the size of the house is 100 square feet, this is the predicted housing price. Here I just put on top of the y something like caret symbol. This is your predicted housing price, predicted output variable, or predicted housing price in this case. So this is the predicted housing price. Got it? Okay, now if I ask you a question, okay, let's say the beta naught value is 1325, and plus the beta 1 value is 2, and they say here the x1, right? This is multiplication, okay, not x, okay. Here, if I say, let's say, if I ask you, what is the estimated housing price for the house which has a size is 1500 square feet? What will be your answer? All of you, please type it in the chat window quickly so that we can fast track it, because everything we discussed in the previous session. If I see, your model already got trained, right? You computed the model already computed this beta naught and beta 1. You don't worry about that, okay? How it computed, don't rationalize too much. These values are readily available. So this is the value. These are example values, okay? This is not a constant value. The sample value I gave it, okay, for the sake of demonstration. Okay. Now, if I ask you for 1000 square feet, the estimated housing price is 3325. For the 1500 square feet, what is the estimated housing price? 2000, 2 into 1500, 3000, right? Plus 1325, 4325. This is for the 1500 square feet. This is the predicted housing price. That's all right. Yes, correct. One second here. Somebody's. Yes, Dinesh, you are correct, right? How about others? Yes, you are correct. So this is the house. Very simple, right? All you need to do is just plug in the values. Only thing is beta naught, beta 1, you do not know what the values. That is given by your model that estimates and gives you the value for beta naught and beta 1. Now your job is simple. All you need to just plug in the square feet, number of square feet for which you want to estimate the housing price. Just plug in here. This is what your simple linear regression all about. So what is multiple linear regression? Instead of having only one input feature here, okay, instead of having only one second, only one input feature square feet, you will have more than one input feature. So, okay, what do you mean by input feature? Input feature is nothing but the square feet, the all the columns, okay? And for in the case of multiple linear regression, what will happen? I go to the next slide. One second. In the case of multiple linear regression, the intercept remains same, right? Only one intercept is there, that is same as your simple linear regression. And this one, but the slope, right? You have multiple slopes, more than one slopes for the corresponding input features. The same thing I just write it. Y is your housing price, and let's say beta naught is 1325 plus your beta 1, right? So beta 1, this is beta 1 and beta 2. I just write it here, beta 2 and beta 1, okay, not B1, beta 1, beta 2. So this is your intercept. It is computed by your model. Similarly, for beta 1, beta 2 also your model will compute it. And what is this is x1, right? This is x1 and x2. So here the square feet less than 1000 square feet, and for that the beta 1 value computed by model 2 into square root, beta 1 into x1, this one, okay, 2 into square feet. The square root is 1000 here, okay. And then similarly, I have like square feet, I have some other features, okay? And for that, beta 2 x2, right? So this is your beta 1 and x1, and this is your beta naught, and plus here you have the slope for your, let's know this is your area, okay? Here, for the sake of simplicity, I just say, again 2 into the area. Sorry, age of the house. Okay, age of the house is, let's say, 5-year old. Okay, 5 year means, 2 into 5 is 10. And here beta 1 is your 2, and the x1 is square feet 1000. 2 into 5 is 10. Okay, if you solve this equation, 1325 plus 2000 plus 10, 2010. Okay, 2010. So which is nothing but 3335. This is the estimated housing price for the square feet, 1000 for this 1000 square feet, and the age of the house is 5. This is the estimated housing price. In this case, we have more than one input feature, square feet, age, right? The intercept still remains only one, but the values, differs based on the data that you train it your model. Okay, this is your intercept, and this is your slope one. This is your slope two, beta naught, and sorry, beta one and beta two. Beta one is your slope one, and beta two is your slope two. Okay, so if you plug in this value, right, wherever the input features are there, right, you just plug in the value. If somebody is asking, hey, can you tell me, for the 2000 square feet and 10-year old house, what is the estimated housing price? Very simple. You just put the value here, right? 2000 square feet and age of the house is 10. That's all. You will get the estimated housing price. Okay. This is how the simple linear regression, multiple linear regression algorithm works. It's very simple, isn't it? Jana Ishwaran, are you able to understand? Jana Ishwaran, very simple mathematics, high school mathematics. That's all. Shubham Paul. Shubham, what is your background? I just want to know quickly. This is what our multiple linear regression algorithm. What else you need to learn as part of linear regression algorithm? Correlation. Before we go ahead and train our linear regression model in Python, certain basic things you should be knowing it. Okay, what is um, correlation in linear regression? We discussed already. We have something called positive correlation and negative correlation. Right, so the two things we discussed it. Okay, and it's something like a ECG report, something like your ECG report. If you see your ECG report straight line, what will happen? What does it says? That means the patient is no more. Okay, using correlation, we can find out the relationship between the two numerical features. I just write it here. One is positive correlation, and then the second one is negative correlation. Positive or negative correlation. What is positive correlation? It measures the relationship between both the input and output. For example, you have something like this. This is your x-axis, this is your y-axis, and let's say right in this case we wanted to find the relationship between two quantitative variables. Here, let's say here the sales. In the y-axis I plotted the sales. In the x-axis I plotted the price. Let's say, as the price increases, let's say 100 to 150, 200, 250, what will happen? As the price increases, so initially my price was 100, the sales was, this much. And then I increased to 150, I could see a, dip in sales. Okay. Don't, consider the high demand products. I'm not talking about high demand products. Okay. And here it goes down. So as the price increases, the sales also decreases. That is what we can see it here. Am I correct? As the price increases, the sales also decreases. Okay. What is negative correlation? This is what negative correlation. This is not positive correlation, except it's a negative correlation. Okay, what is the example for positive correlation? Same thing, but this time I just put the sales in the y-axis, the same thing. But in the x-axis, what I do is advertisement. I spend, initially $100, and then I spent $200, $400, and $800. The more the money I spend on advertisement, I could see a upward trend. I could see a increase in sales, right? If you connect all the dots, you will get a straight line. This straight line is in the upward direction, but this straight line is in the downward direction. As you spend more in the advertisement, the sales goes high. This is what the pattern we can see. So in this case, both the add numerical value or the quantitative variable and the sales quantity variable, both of them are linearly correlated, positively linearly correlated. There exists a correlation between linear correlation between these two quantitative variable. This is a positive correlation. So this is a negative correlation. As the price increases, but still there exists a relationship. But here it is an inverse relationship. There exists an inverse relationship between sales and price. The interview, if they ask you what is the relationship exists between sales and price, right? You can say there exists an inverse relationship exists between these two features. Okay, let's say if I plot something like this, right? So I spend more on my advertisement and my sales, if my sales remains flat, what does this say? Something like ECG report. Patient is no more. That means even you spend more, I don't see any increase in sales there, right? There is no effect on spending money on the advertisement. It is waste. Okay. So you have understood the positive correlation. This is the positive correlation. And then the negative correlation also we have understood. Positive correlations as the value of your X increases, the Y also increases. The negative correlation as the value of X increases, the Y decreases. The value of Y is decreases. If the correlation is stronger, linear regression fits well. Otherwise, you have to use non-linear model. That could be better. Okay. So in this case, previously we have discussed housing price is equivalent to, this is what your Y, and then your intercept is your beta naught plus the size of the house, right? Size of the house is, 1,200 square feet into, the beta 1 value is, let's say 2, okay, hypothetically, okay, 2. Okay, so in this case, let's say beta naught is 1, okay, for the sake of simplicity. So 2 into 2,200 is 2,401. This is what your estimated housing price. As the square feet increases, the estimated housing price also increases, right? What if the slope value is negative? The slope value is negative. What will happen is your, this one also will get rid. That means, right, every 1 unit increase in your square feet, it reduces the value by, this much. That is how you need to understand. Anyhow, that we will see it little later. Okay, now you understood what is positive correlation, and so for that, right, we use a notation called OR. The R is nothing but correlation coefficient. The range of values, the range, the value of R ranges between -1 and +1. Okay. Okay. One second. Okay. So the value of R, right, ranges between -1 and 1. Okay. And what is 1 and -1? Any value that is closer to 1, that means there exists a strong relationship between the two numerical variable. Okay. There is a two. So there is a, of the R value is equal to 1, there is a perfect positive correlation. I just write it here. For example, see, okay, here you have seen it, right? So with this, you can see that there is a upward trend, right? As the value of X increases, the Y also, the sales also increases. Fine. So here, fine, this is fine. Maybe your line will be like this, or it will be slightly, it will be like this, or it will be like this. Now the question is, with this visual, I can make out there exists a relationship between these two variables. Okay, these two variables. These two are numerical variable, right? Quantitative variable. Fine. How strong the relationship? By visually looking at it, we can understand there exists a relationship between these two quantitative variable. How strong the relationship? Somebody is asking you to quantify this. How do you quantify? That is where the R comes into picture. Okay. This is called correlation coefficient thing. Okay. This is the notation we use it. The value of R ranges between -1 and +1. If the R value is 1, that means there is a perfect correlation between add and sales. Okay. Or let's say if the R value is somewhat, R is equal to 0.80. That means there is a 0.80 correlation is there between these two variable. How strong it's something like simple example, right? So in a same house, husband wife lives. They have a relationship, right? Husband wife, that is the relationship. How strong the relationship? Can you quantify that? Right? This is just for, maybe it's a stupid example. For you to, understand in a very funful way, I just use this example, okay? Okay, there exists a correlation between these two numerical. How strong the variable using this, or we can define it. So there is a formula for or, okay? I'm not going to talk too much of math, okay? There is a formula for or. Anyway, you don't have to worry about computing the value for or. Everything is taken care by your package. The Python software, it takes care of it, okay? So let's say your R value is 0.80. This is given by your Python. So with that, you can say, hey, there is a relationship between these two quantitative variables. These two variables are correlated well because the R value is 0.80. If the R value is something like -1, there is a perfect negative correlation. As yes, X increases, the Y decreases. A perfectly straight line. Okay. But still, there exists a relationship. Okay. Or equal to -1 means in the perfect negative correlation. Okay, let's say what kind of situation give me some other the example for this one. Take for example in the case of retail store where discounts increase, right? Let's say you have something like this. In the way the x-axis you are giving a discount, and then the x-axis you have the profit. You plotted the profit. When you give more discount, what will happen? Your profit will go down, right? Right? If the store gives 100% discount, they make zero profit. So this is another example. Okay. So your discount and profit. If the store gives 100% discount, right? What will happen? It will be straight line. This is a perfect, yeah, that means they make a zero profit, right? So the more the discount you give, what will happen, right? So it will go down, 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 right? So and finally it comes down also, right? Minus somewhere -1, okay? Minus profit, okay? And any other example for this one? Speed and time, speed and time. With this example, I'm going to stop it. We will proceed further because we don't have time. And for example, other example is the more you increase your speed, you reach your destination fast, right? The time and speed, okay? As you increase, sorry, the time, sorry, as you increase the speed, the time is decreases, right? For example, initially, you go by let's say 10 kilometer speed, and then 30 kilometer speed, and then 50 kilometer speed, and then 70 kilometer speed. What will happen? Right. So your the how much time it will take for you to reach, right? As the time increases, sorry, as the speed increases, the time decreases, right? So here it may be slightly here and it will be slightly here. The lesser the speed you go, more the time it takes to reach your destination. Okay, so with this, what we can understand here, if you go at a maximum speed, the travel time becomes very less. This is a perfect negative correlation, or equal to -1, right? So what is the final takeaway? If R is closer to -1, there is a stronger negative relationship between X and Y. If R is close to 1, there is a strong positive relationship between X and Y. If R is 0, there is no relationship between X and Y. If you give 100% discount, what will happen? You don't have any profit. Okay? You sell it at the cost price only. Okay, fine. What is the next topic? So now you understood what is positive correlation, negative correlation. You just if somebody tells you what is correlation coefficient, the first thing which comes to your mind is R. The next thing is the value of R ranges between -1 and +1. +1. Any value closer to 1, that means there exists a stronger positive relationship. Any value that is closer to -1, that means there is a inverse relationship exists between those two quantitative variable. This is the thing that that needs to come into our mind. Okay. Next, what we'll do is we will discuss about the intercept. Okay, what is intercept and slope? Okay, what is intercept and slope? And I explained you in the previous session. The intercept is something like the line which touches your y-axis called your intercept. Okay, what I will do is right. I'll just draw the picture here. And here the square feet in the x-axis, the y-axis the housing price. I plot it here as the square feet. For example, 1,000 square feet and 1,500 square feet and 2,000 square feet, 2,500 square feet. Obviously, as the square feet increases, the housing price also increases, goes high. Okay, the housing price also goes high. Okay, and when you draw a straight line, right, by touching all these things, right, all these values, this is called your regression line, linear regression line, linear regression line, which is nothing but y hat is equal to beta naught plus beta 1x. Okay, and see if somebody is asking you, can you tell me if the square feet of the house is 1,800, what is the estimated housing price? For example, here I just put some random values for these. Let's for the square 1,000 square feet, the housing price is let's 1C. And here 1,500, 1.5 C, 1 per crore, okay, and 2 crore and so on, okay. And somebody is asking, hey, if the size of the house is 1,800 square feet, what is the estimated housing price? And if you draw a line which touches the straight line, and also horizontally, if you draw a line which intersects with this one, right? Sorry, slightly here, okay. And you can say this is your 1.5, see almost right. So 1.6 or 1.65 crore. You join these two lines, right? Right. So where it intersects, sorry, here it intersects here, and if you put it here, 1.6 crore. You can say easily like that, right? So with this, by plotting this chart, we can easily tell the estimated or the prediction, right? Predicted housing price, we can tell by plotting this. Is it clear? Okay. So this thing, right, the line where it touches the y-axis, that is called your intercept. This is called your intercept, and the slope is something like this. This is your slope. Okay, this is your intercept. Okay. So what exactly the intercept tells? If somebody is asking you, you can tell, hey, the line, in the case of linear regression, we are fitting the straight line. The line, the straight line where it touches the y-axis is called your intercept. Fine. This is from the academic point of view or theoretical point of view. Fine. But the business person, he will tell, right? You don't tell me intercept all the stories, man. You tell me what is this exactly from the business point of view, right? That means, right? For example, here I just tell you something like this. Y is equivalent to your intercept is, let's 1.03 plus your beta 1s slope is less 2 and square feet is 1000 square feet. This is your size. Okay. And 2000, 2 into 1000 is 2000 plus 1.03. And when you add these two things, whatever you get, that is what your estimated housing price. Okay. And what exactly the intercept is all about in this case? For example, if the square feet is 0, what is the estimated housing price? Then, this one will become 0. 2 into 0 is this part will become 0. So 1.03. You might be wondering, the Y value, even though I don't buy even a single square feet, they are charging me 1.303. This one seems to be completely illogical. Sometimes the intercept is not, sometimes the intercept is not helpful. Okay. Right. It's kind of a useless thing, the intercept. I'll take another example. I want to predict the sales. So what is the, how much sales I can expect for the next month? Okay, my intercept value is less, 1020 plus my slope is less, 3 into sorry. Let's say you are spending $1,000 in advertisement. Okay, and this is computed by your model. This is computed by model. Okay, and in this case, what is the predicted sales? 3000 plus 1004020. This is the estimated sales or predicted sales for the next month. We can say that way. Now the question is, if I don't give any advertisement, 3 into 00, this part will become 0, right? So now even if I don't give advertisement, what it says is, in this case, the intercept value is 1000, which means if you don't spend any money on the advertisement, the estimated average predicted or estimated or the predicted average sales is 1020, which means, right, if it doesn't mean if you don't give any advertisement, customers will go and buy it, right? Still, customers are going to buy it from your shop because your let's your shop is in the prime area of street. Okay, so obviously the customers will come and buy it. But if you give advertisement, it will increase your sales. If I don't give you any advertisement, in that case, your intercept is helpful, right? Even if you don't give any advertisement, the estimated average prices, estimated is nothing but predicted. Predicted average sales. The predicted average is 1020. Still, you can answer this one. But here, in the case of housing price prediction, the square feet is 0. If you give, what still you'll say, 103, 1.03. Okay. So in this case, it does not make any sense. Okay. You remember intercept, is not helpful in some cases, but whereas in some other cases, it is really helpful. Okay. So now you understood what is the intercept, is how to interpret the intercept. When the value of your x is 0, when the value of your x is 0, what is the estimated average sales? That is what your intercept is all about. This is how you need to explain to your business team or your stakeholders in your company, because they don't know the ABCs of the statistics or linear regression, all the things. Okay. Now, so what is this slope is all about? What is the slope is all about? Slope is nothing but this is the value, right? So as let's say, when you increase $1 in the advertisement, how much increase in sales you can see it. Okay, when you increase the 1 unit in advertisement spend, how much you can expect this? If there is a 3 times increase in your sales, right? 3 times. For example, if you for every 1 unit increase in your, because your slope is 3. Okay, if I spend 1001, what is the rate of change in my sales? So 3 into 1001, right? So that is what the rate of change. The slope is nothing but what is the rate of change in y when x changes? Rate of change in y when x changes. For example, instead of 1000, right? If I say 2000, what will happen? From 1000 to 2000, right? When x changes, this is where x. When x changes to 2000, how much change in y you can see that? 3 into 2000, how much? 6000, right? Almost 6000. 3 times your sales will increase it, right? So 3 times your sales is increases. So when, in this case, right? When if you are if you spend $2,000, you can expect 3 times increase in your sales. That is what we can see, right? So you spend 2000, and what is the estimated sales that you can, or predicted sales? So in the, since the slope is 3, we can say upfront 3 into 3 times of your 2000, which is 6000. 3 times your, that is what's the slope is all. What is the rate of change in y when this exchanges? When the exchange is to 2000 in this example, the y changes 3 times. The sales changes to 3 times. In addition to that, you need to add this one also, okay, the intercept also. Very simple. When the value of x equal to, when, okay, I'll just write it. When x equal to 0, what is the estimated or the predicted? Estimated, in this case, price, right? Estimated price, estimated average. You need to put average. Estimated average price of the house from the, this is what your intercept. When x equal to 0, when this is your x, right? This is your x. When x equal to 0, so 0 into 2 is 0, right? This portion will become 0. This is the estimated average price of the house. Okay. And what is slope? The rate of change in y when x changes. What is the rate? Or we can say what is the what is the rate of change in y when x changes? So in this case, the sales increases 3 times when the value of your x changes. In this case, the x is your advertisement spend. When you spend $1,000, it increases by 3 times your sales. When you spend 2000, it increases by 3 times. When you spend 3000, it increases by 3 times. Right? How much the value of y changes when the value of x increases or changes? That is what your slope is all about. Hope you understood this one, right? Next one, okay, enough theory. We will jump into the hands-on part so that we will be able to understand, right, what exactly happening when I actually fit or train a model in the Jupyter notebook or so. Okay. So here, if you see, this is my Jupyter notebook. All you need to just go to the Google and type download Jupyter or Anaconda. Okay, Anaconda Python. Download Anaconda Python. And then if you go to that link, right, you will find the place where you can download it. Once you download the Anaconda Python, install it. Very simple. Okay, or else you can watch my video. It is there already in our website. Okay, once you install the Jupyter notebook, next thing is you can go to the start button, type Jupyter notebook. And don't say, I know VSC. If you know VSC, Visual Studio Code, you can use that to write your Python programming script. Or you can use Jupyter Notebook to write your Python. So usually what we do, right, data scientists, we use the Jupyter Notebook to explore the data, all the things, okay? So, and then once you go to the start button and if you find the Jupyter, click on open. It'll take some time. You need to have some patience. You will find something like this. This is your Python kernel. And then you will find something like a local host. Okay. And here you will find something like, you will find something like this. Okay. 4448, right? Local host. You just copy this and paste it in your Chrome browser also. And then wait for some time. It will bring up a Jupyter Notebook dashboard, something like that. And then what you do, right? You can find something called new on the right side. Click on the drop down and click on the new book. It will open up a new notebook. That is where we will write our Python script. Let's say in my case, I already wrote the script here. Okay, I just clicked on the notebook. It opened up and I imported all the packages that are relevant to train the linear regression model. Forget about all the things. Okay, I just click on this. All the packages that are required to train my machine learning model called linear regression. Okay, fine. Next one is to train my machine learning model. I need to have the data set, isn't it? So this is the data set I'm using it. I just load this data set, which is available in my folder called dat1 in the E drive to a variable called HDF. This variable HDF will become a data frame. And if you type hdf.8 file, which means, right, display top 5 records from this data set, from this data frame, okay? It shows, 5 records from the beginning. And here also we can see the column name, size of the house, and then undivided share, and how many number of parking lots are there, parking lot parking lot size, and the MISC, other, miscellaneous common area, and then the price also is there. The first four are your input feature. This is your output feature. We need to, you train our model with the combination of these two, the input feature and then the output feature, the target output feature price. Okay. Now that we could see this data, and the next one, what I do is I'm going to use something called shape. Shape will give me how many number of records, how many number of columns. Guys, in the interview, they'll ask you to check, how good are you with pandas package. This is called your pandas. PD stands for pandas. They'll ask you, how do you find out the total number of records and columns in a table? So shape. Okay, this one. So in this we can see. Now you might be asking, but it shows only 5 year. How come it shows 148 rows? Because I use head. Head of 5 means display only top 5 records. Don't display all the records. Fine. Now we could see that, and the shape, with the shape we can find out. It's always a good practice. Don't display, don't give HDF alone. If you give HDF and if you click on the run button, it'll display all the records that are available in the data frame, which is nothing but your housing data, this data file's data. But let's say this data file contains 100,000 records. It will take longer time, right? It will consume too much of memory in your laptop. So always a good idea, start with the 5 records and 10 records. View only top 5 records, top 10, top 100 records. That is enough. But if you wanted to know how many number of records that are there here, shape, right? This is your data frame name, dot shape. This one will give you total number of records and total number of columns. And then we have something called pair plot. This is the chart that is available. With this, the x-axis I'm plotting all the input feature, and the y-axis only one dependent variable price. I, plotted it here. You remember the correlation I explained a while back, the positive correlation, negative correlation, all the things, right? So the same thing here, the size and price, these two are quantitative variable. We are finding out the relationship between these two numerical variable, using the so using the correlation plot. Here we can see that, the size and price, right? Where, almost all the values are somewhat closer, except few values that are little far away from this line. This line is your best fit line. It is also called as a best fit line or regression line. Okay, so you can see, the as the size increases, the price also increases steadily. We could see an upward trend. There is a positive correlation exists between these two. Hence, we can say the size is your output, this is your input. These two variables are correlating very well. Similarly, undivided share and price. Undivided share is also numerical value, because in this one we stored the square feet. How much square feet of undivided share is there? Right? If I plot this one, it is not as straight as this one, but still, right? It draws a straight line, and almost all the values are kind of okay, right? But still, we could see some kind of deviation. These values are too far from the line, but still, right? Compared, is little bit tilted on the in the downside, right? So you can see this one. So still UDS and the price also kind of correlated, but Park and MISC is kind of straight line, right? So it is tilted further in the case of Park, and these two input features are not correlated well with my price. But still you will get confused, right? So but it's not a flat, right? We cannot say there is no relationship exists between Park and say that is where the correlation values are helpful. So you have something called hdf.core function is available that gives you the value of the correlation between the two independent, after it's two numerical value, which is nothing but your input feature and the target output feature. The input feature is size and all that. What is the relationship exists between these two variables? There is a linear regression. How strong the relationship? So in this case, if you go to the chart here, price and size, you see 0.8. 0.8 is closer to 1. That means this size is correlating very well with my housing price. Hence, we can include this feature in my model to train my data, to train my machine learning model called linear regression, right? And similarly, UDS, you can see all the input features, correlation values, along with the target feature called your price. And these two are correlating well, and these two are kind of correlating, but the Park and MISC, the call point 0.2, which is nowhere closer to 1, right? So it is closer to somewhat, 0, right? So hence there is no correlation exists between Park and price and MIS and price. So there is no point in including these two features to train your machine learning model, which is nothing but linear regression algorithm. In the case of linear regression, remember very well, only when the input and output features are correlating well, then you can include them in your model. Otherwise, simply remove these columns from your model. Here, what I did, all the input features I mentioned, I have used the x and y variable. In the x variable, I put all the input features. In the y variable, I put the price. That's all okay. And then what I do, right? I use train and test split. Okay. So train and using which what I do, right? The X is nothing but all the four input features, the size of the house and UDS and what else? UDS and the park and MIRC, right? So those are your input. The Y is your housing price. Okay. And test size equal to 0.0. See, what we are doing is, let's say your manager gives you 100 records. You need to randomly split the 100 records by, 75, 25. The 75% of the data, use it for training your model. Once you train model, you need to test it, right? But you need to use the test data set which your model was not trained. So that, you can, with that, when you apply your trained model on the unseen data, you will get to know the objective values, right, about the performance. Okay, so just forget about, see, here what we have to do is, right, take the entire data and then split it as a 75-25 ratio, and 70% data use it for training data set, remaining 25% use it for test data set. Okay, next step is, right, I'm going to import the linear regression class. Okay, here already imported the linear regression class, just above. See, this is your linear regression class that is available as part of your package called sklearn.linear model. From this package, I imported this class already. Now, importing alone not something, you have to use it, isn't it? So what I'm doing is I'm going to initialize the class linear regression here and assign it a variable called initFit. Okay, this is nothing but your linear regression. Okay, and here the init fit, I'm going to use it here because this is what your linear regression dot fit. Okay, if you guys remember the fit and predict, you are almost you have already crossed 50% of learning the machine learning algorithms. Okay, the fit and predict is common for almost all the machine learning algorithms. Okay, so now I just use the linear regression instead of linear regression, init fit, right? Init fit dot fit and all the input features and then your output feature. These are housing price and here all the features, remaining features. What are the remaining features? Dhyanesh, size of the house, undivided share. Dhyanesh is a real estate person, okay, a real estate gentleman, okay. And here the input features are, the size of the house and then the undivided share and parking lot space plus the common area space, right? All those things, I mentioned it, in this data set, in this thing. And here, housing price, because we need to train our model with the input features and then output feature. Okay, the input is all the square feet, all the things. Okay, the output is price, right? So you need to train your model with this one. Once you train your model, you will find the coefficient. This is your beta naught, sorry, beta 1, beta 2, beta 3, slope values. We discussed about slope a while back. These are the slope. This is the slope value for your size of the house. This is the slope value for your undivided share. This is the slope value for your park. This is the slope value for your common area. Okay, common area. Okay, what about the intercept? Look here, the intercept and beta 1, beta 2, beta 3, beta 4. Because it's a multiple linear regression, we are using four input features. For each input feature, we got the beta 1, beta 2, beta 3, beta 4 core, the slope values automatically. The intercept values, we got it. Like I said here, right? Simply you need to plug in the values. That's all. Okay. And you will get the estimated housing price. Now, what I did, I just trained my linear regression model using the training data set. Okay. Now, my model got trained. My model name is model. Now, what I do is I'm going to take the trained model and then apply on the unseen data. I told you, right? You need to split the data into 75-25. The 25% of the data is there in your test data set. Now I wanted to apply the train model on the unseen data, which is nothing but the test data. Now, and then what I do is I predict this one. So I want to apply this model to predict the housing price for the unseen test data. And then I store it in a variable called pred. And then I just type pred, and when I click on the run button, it gives me the estimated housing price or predicted the housing price for the test data. Okay. So up to this, you are great. So guys, remember fit and predict. Fit method and predict method. That's all. This is a fundamental thing for all the machine learning algorithm. Fit and predict. So fit, when you will use it to train the model. Any machine learning model, you use a fit. Okay. So as part of fit method, what are the arguments that you use it? Input features and then the output feature. Okay, you train the model. So what is the next step? We need to use the train. We need to use the model, right? Training the model is not sufficient. We have to use it. Yes, I used it here. So and then what I do is, right, I'm telling the train model, hey, go and predict the housing price for this, new houses. New houses in the sense you did not see this data because I did not train you on the test data set. I trained you only on the training data set. Now consider these are the new houses, right? So you what you do, hey model, you go and predict the housing price for this new data, new houses in the sense, new houses, the input features are there except the housing price. Okay, so with that, it predicts the housing price for all the new houses or the test data related housing price. This one I'm going to skip it. The next step is okay, I trained the model and then I predicted the model. Fine. Now I wanted to check what is the accuracy of my model. A simple example. Let's if I Dhyaneshwaran, if I ask you, so what is the chances that tomorrow it will rain? Can you predict and tell? Let's say you are an expert, right? You predict and tell tomorrow it will rain almost, there is a 80% chance it will rain tomorrow, Satya, if you tell me, right? So that means, right? Okay, what I do is I literally go by your word. What I do, right? Tomorrow I will wait. Tomorrow whole day I will see to that. If there is no rain, what I will say? Your prediction was not accurate. Dhyaneshwaran, are you agreeing with me or not?
Yes, sir. Yes, sir.
Right? Are you able to understand?
Yes,
Similarly,
sir.
right? Like human can make the mistake, a wrong prediction, the machine learning model can also make the wrong prediction. You need to check that one. How do you check that? That is where you have something called metrics. Using metrics, you can find out how well my model predicted. What is what is the prediction accuracy? Is that the accuracy is 90% or 95% or just 60% or 50%? Any value closer to 1, that means the accuracy is good. So what we are doing, right, we are using something called R to score, R squared, okay, and then we are using something called the mean squared error, right? So instead of saying like this, right, there is a 90 percentage, Dhyaneswaran told me that tomorrow it will rain. Okay, let's wait and see. Tomorrow is what is Saturday. Let's say tomorrow, if that rain, let's say, no, he says, right, whole day it will rain tomorrow. There is a 90% chance tomorrow it will rain the whole day. But what happens tomorrow, right? I woke up in the morning, I could see there is no rain. But what happened, the afternoon, right? After 3 p.m. it started raining it. Right? Then whatever he said was correct. There is a 90% chance it is raining. So his prediction accuracy is correct, right? So maybe, right, 90% chance whatever he said, right, it'll, it happened correctly. He predicted 90%. There is a 90% chance that it rained really. Instead of saying this way, so what is the error accuracy? But he said 90% chance it will rain. The remaining 10% it will not rain, right? So his prediction accuracy was 90 percentage, but still it did not rain. What do you say? There is an error, right? So how much error is there? Higher the error, higher, lesser the accuracy of your model. Higher the error, lesser the accuracy. This is the simple. Another example, for example, I'm asking Dhyaneswaran. Hey, Dhyaneswaran, I want to buy Wipro stock price. Today, I could see that 1,200 rupees. If I sell it next week, how much can I get profit? So what is the actual price? 1,200 today. But he predicts and tell me, hey, if you buy it now at the cost of 1,200, next week by Wednesday, it will go by 1,800. Next Wednesday, it will go by 1,000. It will increase by 1,800. How much today's price? 1,200. What is the difference? 600. What I do, right? I just literally go by his word, and then I bought 1,000 Wipro shares, and I wait. The next week, what happened? Next Wednesday, I am just I woke up early. I sit next to the monitor and keep on monitoring it. How what is the price, right? If the price he quoted by 1,800, the actual price was the one I spent, right, 1,200. But next Wednesday, let's assume that, right? Let's say today is Wednesday. Now I'm just looking at the charts, everything curiously. So 1,200 is said, but now the price is gone up only by 1,000. Let's say 1,205 rupees only per share, only 5 rupees profit. What is the prediction accuracy here? So 1,000. What is the actual price? 1,200, and the predicted price was 1,800. The difference was 600. That means, right, the actual price on the Wednesday was, I just write it here, guys. Don't get confused. If I keep on talk and if I don't write it, you will get confused. Okay. See, Wipro price today, okay? Today the Wipro price is less than 1,200. Just assumption, okay? And then what he says is, right, if you buy the cost of 1,200, next Wednesday, you will get 1,800. This is what he says. This is the predicted or forecasted price, okay, by Dhyaneswaran, okay. I literally go by his word, and then I bought, let's say 1,000 shares. 1,000 into, 1,800. Sorry, 1,000 into 1,200. 1,000 into 1,200. Okay, fine. So what happened? Today is, today is Friday, and now I wait until next Wednesday. Let's assume that today is Wednesday. This is the today is Wednesday. Last Friday I bought it 1,200 per share. And today I'm just checking it, with curiosity. How much the price? Let's if the price on this rate 1,200 and 1,300. 1,300. That is the actual price on the Wednesday. Okay. This is your cost price. Okay. You just think that, okay. Okay. And this is where on that Wednesday, instead of 1,800, 1,300 only, the price got 100 rupees increased per share. So what is the, the prediction accuracy in this case? If I ask you, this is your actual, right? This is the predicted. So the difference between these two, 1800 minus 1300. How much difference? 500. Okay, this is the predictor, right? So this is a different. This is called error. It's called error. Okay, how much error? For example, right? You said 1200, but the today is Wednesday. Okay, last week he said last Monday he said 1800. I can get it on today. Let's assume that Wednesday. So 1800 and today price also the actual price was 100,800. If you subtract the predicted price by Dhyaneshwaran with the actual price 1800, zero, right? Zero error. That means his accuracy was 100%. And here what happens? Right, same thing, right? This is the predicted price by Dhyaneshwaran. This is the actual price. If I separate, the error is more, right? At least, if it is closer by, for example, the predicted price was 1800. The actual values, this is predicted, and actually something like 1750. What is the difference here? 50 only, right? That means that difference, the error is less here. This is called error. The difference between actual and predicted is called error. So lesser the error, higher the accuracy, right? Okay, very good, man. So just 50 rupees only difference was there. Very good. But still, his accuracy is somewhat, matching with my thing. Very good. Actual value. Just 50 rupees only difference is there. This prediction accuracy is really good. In this case, what is that? The 50 divided by the predictor 1800, right? So this is the one will give you the percentage, right? That is the one will give you the percentage. Okay. That's something like this is the one will give you the percentage, right? So the predicted minus actual divided by the predicted value, right? So that is the one will give you the percentage of accuracy. But simple term, right? The error is 50 in this case. We predicted 1800, but today the price is 7,750. But the difference is less. But in this case, what happened? He predicted 1800, but 1300 only the actual price on this Wednesday. The difference 500. That means is the prediction accuracy is not that good. The actual and predicted is somewhat close by. That means the accuracy is good. The error is less. Lesser the error, the accuracy is more. So hence, what we are doing is we are computing the error. If the error is less, then my model accuracy is good. It will not be always right. The predicted and actual will be same, right? There will be some variation, but the error should be variation should be less. So now what we are doing, right? We train the model and we predict the model. Next, what we are doing is right. We are using some packages. In this package, what we are doing, right? We are passing the actual and predicted value. The predicted value by Dhyaneshwaran. This is the one, right? This is the one is the predicted values by Dhyaneshwaran. This is the actual value on that Wednesday. If I pass this, it'll subtract the predicted value. If it will subtract the actual value from the predicted value. This were actual value and this were predicted value. It will subtract your actual from predicted value and it will give you the error. Lesser the error, is accuracy is good, right? This is how we can evaluate how well my model performs. Training a model is not sufficient. Okay, once you train your model, it saves your time. You can predict thousands of houses, 1 million houses in a matter of seconds because you already trained your model. Your model is ready. You throw 1,000 houses data is in its. Sorry guys, some problem happened with my net connection. Suddenly it went off. So now we understood how to train a model and how to make a prediction and how to evaluate your model performance, right? We have something called root mean squared error. If the lesser the error, the better the accuracy of the model. That is what we are going to do. Next one is linear regression assumptions. If the error is less, that your accuracy is good. The model is predicting well. Okay, fine. And apart from this, right, estimating your model or evaluating your model using root mean squared error. If the error is less, your model is good. You tested your model also good. That is not sufficient. In addition to that, you need to validate 5 assumptions. What are the 5 assumptions? Linearity. Linearity is, the each independent variable input feature should be linearly correlated with your dependent variable. For example, size is your input feature that should correlate with your housing price. That is what we have seen it earlier, right? This is your core plot. So here the size is correlated very well with price because the correlation is 0.8, which is closer to 1. Very good. Here 0.2 is not close to 1. It is close to 0. Your 0.2 is, is also close to 0. Hence, these two columns are not helpful in terms of predicting my housing price. Drop these columns. But, these two columns I included in my model. I could see that there is a strong relationship between these two, which means, right, there is a linearity. There is a linear correlation exists between these two variables. Hence, my model satisfies this assumption. See, even if your error is less, and you can say your model like this is good, you tested it fine, but still you need to go ahead and conduct 5 more tests.
हाँ, sorry to
Yeah. Hello.
Mm.
Right. So next one is independence. The error is supposed to be when you plot the errors, it should be independent of error should be independent. Okay, there should not be any correlation between the errors. Okay, for example, house one, house two, house three. House one, the difference between actual and predicted error you are getting right. For house two, you get error, and house three you get. So each error should not be correlated. That is what this one says. And then the homoscedasticity. So these three we will discuss it in the next session because if I talk too much, you will get bored. And what I will do is I will give the script and what you need is I will send the data set also. Okay, send the data set also. In your laptop, what you do, you just download the data set, whatever I send it, housing data.cs, I'll send it to you. And then what you do is, make sure that you create a folder called dat1 in your laptop. Let's say you don't have E drive. In this list, you have D drive. Okay, in the D drive, you download the housing data.csv and then create a new folder called dat1. In that folder, you put this file. Is this clear, Janeshwaran? So I'll send this data set, you download it, and then you create a folder and put it, this file in this one. And then you need to make sure that whatever the drive, you put this one in. For example, D drive, you create a folder called that one. In that, you put this file. And then if you execute it, it will work fine. Okay? Because you need to tell very clearly where this file is available in your laptop. Without this file, this script will not work. It will throw an error. This is clear? Okay. Next one is simply go to the next line and click on execute it and then see what happens, right? And then you watch my previous video, previous batch video, and then try to understand technically also. That's all. Okay. So, but remember one thing, the fit and predict, these two, you need to remember it. For any machine learning model, especially the supervised machine learning model, we use fit and predict. Okay. Anyway, we will talk in detail in tomorrow's session. Don't worry. Okay. Tomorrow we'll discuss about this and we will complete. that will help you to crack your MLOps interview and all toward the Saturday, Sunday session. Tomorrow is Friday. Attend tomorrow also the linear regression, the continuation of this one. Tomorrow I'm going to talk in detail everything. Okay, and that's all, guys. Okay, you have any questions as of now? Okay, cool. Since you don't have any questions, I'm going to wrap up the session and I will share and I will upload the videos. You all can watch my video and without fail, watch my video and then practice it side by side. Okay, thank you guys. Bye.